Well, welcome everybody. I think we can start to get going on today's session. My name is Lisa King, and I'll just start by welcoming you all. I really appreciate all of your attendance to our first stakeholder engagement workshop, #1, for designers, consultants, and specifiers related to this very important topic around embodied carbon. We're going to be talking about a couple of really important groundbreaking studies that have been underway for buildings in Ontario, and trying to get your feedback, the most important part, on the work that we're doing to move towards our policy and implementation. Next slide, Ryan. So just going over the agenda for today. So we've got 2 hours of your time. The first hour essentially is us presenting to you, going through what we plan to do with the Toronto Green Standard, a little bit on that, and kind of going through some base level, kind of getting everybody on the same page in terms of embodied emissions, what it is, what others are doing, some of the leaders on this, and there is some real leadership happening on this topic across the country. And then looking at the 2 different studies that have been underway. The Part 9 is almost finished, study led by Chris Magwood and Passive Buildings Canada, and then the Part 3 study being the one that I'm more involved in with Mantle and U of T, looking at the benchmarks for these larger buildings. And after the breakout session, so we'll have a very short break, but then the breakout sessions is where we really get into it and want to hear from you for that last hour there. Next slide, please. So I'm a senior policy planner. I'm with Strategic Initiatives, Policy and Analysis at the City Planning Division, City of Toronto. And I'm a lead on something called the Toronto Green Standard. And I'll just mention to you, I apologize for my nasal sounding voice, and if I cough, I'm just kind of in the post-COVID period. So I'll do the best I can to be clear. Next slide, please. I guess, actually, yeah, I'll just mention this now before we go forward, but just that this is, you see all those logos at the bottom of the slides here. This is a really important, Ontario level partnership that's underway here between all of these organizations that are listed there that you'll be hearing from today. But in the City of Toronto, we have something called Transform TO, that's our climate change strategy. And just to mention as a context piece that it's it's one of the most aggressive climate action strategies for a municipality in the country. And in December, our council adopted what's called the Net Zero 2040 strategy. And, meaning that by our citywide target is to be net zero emissions by 2040 or before. And buildings in Toronto make up about 57% of our emissions out of that portfolio of different sectors. So it's a really important sector for us to really try to ratchet down our GHG emissions. And Ryan, you can go to next slide. And, one of the ways we do this, and the tool that I'm most involved with that helps to do this, is something we apply to new development, new construction. It's called the Toronto Green Standard. And it's been in effect since about 2010. And it is a way that we take our official plan policies and our corporate objectives around policy to improve the environment in new development and apply it as a set of performance measures and requirements in the planning, application, and approvals process. It's a tiered system. So tier 1 is mandatory for all new developments. So we've had over 2,000 developments apply the TGS since 2010. And the tier 2 or higher is a voluntary level, but it comes with a very good incentive called the development charge refund. And that tiered system, the benefit of that is it kind of applies the 2-pronged approach, the carrot and the stick, so that we can introduce new important requirements, such as what we're going to be talking about today, to the development industry in a way that's voluntary, where they get used to doing something, it becomes more mainstreamed, and then bring it in as a mandatory requirement when possible. And the TGS, it covers 5 categories of environmental performance. So right now it has about 36 performance measures in it in Toronto Green Standard version 4. And that comes into effect May 1st. So we're on our 4th version of the TGS, and we ratchet up the requirements each time. But it also includes something very important called the Zero Emissions Building Framework. And you can just go to the next slide, Ryan. The zero emissions building framework was a very large building archetype modeling study around operational energy and emissions for Part 3 buildings that we did and costing back in 2017. And what it did is similar to the City of Vancouver, it sets out a tiered or step performance pathway around energy and emissions limits for large Part 3 buildings. So again, around operational emissions. And it was originally set out to 2030. So that what would happen is every time we update that Toronto Green Standard that I've mentioned, we remove the Tier 1. And so that by 2030, originally, today's highest performance level, very low emissions Tier 4 was the mandatory Tier 1. And what happened was with that net zero strategy adopted by Council in December, that pathway, that timeline was moved up a couple of years. And that's what you see in this graphic here. So that by 2028, today's Tier 4 is tomorrow's Tier 1. And by 2025 is our next revision of the TGS. So that shortens the cycle and helps us to move more quickly along this pathway on reducing operational emissions by over 30 megatons by 2030, well, 2050, I should say, in total. And at the Tier 3 and Tier 4 is where we really start to see fuel switching starting to happen, because the targets, the greenhouse gas intensity limits, force that real consideration of moving off of natural gas for heating and cooling and looking at other low carbon sources. But the key thing here is, of course, it was all focused on operational emissions. Next slide, Ryan. So, about a year ago, there was a lot of activity and discussion really starting to emerge, I would say in the Toronto area anyway, and in Ontario about this important new emerging issue. And we've always been aware of it and wanted to introduce this into the next TGS, version 4. But the federal government, NRCan, was working on this. The Endeavour Centre, Chris Magwood, who you'll hear from, was doing quite a bit of work on this topic. And for the City of Toronto as well as part of our existing building strategy. And Kelly Doran was doing quite a bit of work with U of T. And Ryan, of course, who you're going to hear from, has been a leader along the way, working on policy initiatives across the country and elsewhere. And so there was a lot of dialogue starting to happen, and this was being brought to us. And we really decided that based on the urgency of this issue, that we needed to move these studies along faster. So we knew that we wanted to introduce requirements for embodied emissions reductions in the TGS, but we wanted to get these studies going sooner. So we're lucky to have the Atmospheric Fund as a local affiliate organization with the City of Toronto now that offers grants across Ontario, who was able to support, excuse me, both of these great studies that you'll hear about today. And so that we could move this analysis and understanding of the issue faster. Next slide, please. And so for now, in TGSB for May 1st, 2022, what we do have is a voluntary level requirement to do the tracking of upfront emissions from structural and envelope materials, to require that in Tier 2 or a higher level in Tier 3. And for any city-owned buildings, they must do the tracking and reporting. But what we're looking at is whether we might be able to go further with that in 2023 and set out some targets. Now, we have set out some targets in the low-rise Part 9 buildings for now, under Tier 2, the voluntary level 2. Next slide, Ryan. So for today, we really want you to have a lot of time to hear from the leaders that we've got on the agenda today, and I'll introduce them in a second. But the idea is really to get your input, get your feedback on the studies and the potential targets that are being proposed, and to be thinking about from the standpoint of your role as a consultant or as a specifier, what the city should be receiving, reviewing, what kind of policy we might set out, different ideas you might have about that. And of course, we want to hear about any of the challenges. And we will take the results of all 4 workshops that are upcoming, and it will feed right into what is called a policy primer that the consultants are developing for this deliverable, and potential changes, as I say, to the TGS in 2023. And then, of course, future follow-on work, because this can't be the end of the kind of work and study and discussion. So I just want to introduce your 3 main speakers for today and guides on this workshop. So the first is Ryan Zizzo. who is a professional engineer and part-time lecturer at Ryerson University and the founder of Mantle Developments. And he is one of North America's leading voices on embodied carbon in construction. And I'll also just mention, because the speakers will introduce themselves as well, but the next speaker later on will be Kelly Alvarez-Doran, who is an architect adjunct professor at the University of Toronto and the founder of Half Climate Design. And both of those two, Ryan and Kelly, are leading the Part 3 study that we mentioned. And then you'll hear from Chris Magwood, who's the manager of carbon-free buildings at the Rocky Mountain Institute and director of Builders for Climate Action. And he's leading the Part 9 study with Passive Buildings Canada. So that's all I'll say for now. And again, thanks for coming, and I'll pass things to you, Ryan.
Great, thanks so much for that intro, Lisa. Great to hear about the movement with the TGS, and that materials are definitely on the agenda for the new version and updates after that. And happy Earth Day to everyone. We didn't know it was, or we didn't realize it was Earth Day when we set this meeting date, but it was good timing. So I'm just gonna do a bit of a Embodied Carbon 101 and a quick touch on some other policies we're seeing in other jurisdictions. I know some on the call are experts in this topic, and some of you probably are just learning about embodied carbon. So trying to give an overview and make sure that we're all up to speed on some of the basics here. So when we talk about embodied carbon or embodied emissions, what we're talking about is basically the emissions from all of the areas in blue on this graphic. So it's kind of the sum of all of the emissions associated with the manufacture of our building materials, having those materials transported to our construction sites, the actual installation processes itself. So thinking about diesel on site, cranes and lifts and all that kind of stuff. And we also have use phase emissions. So this is more about the materials that we use throughout a building's life cycle, thinking about roof replacements, doors and window replacements, and then end of life, deconstruction, recycling, and transportation in the end of life. So that's all of those together is what we're talking about when we say the embodied carbon of a specific material. You'll notice operational carbon emissions. That's the carbon from the energy we're actually using, the heating, cooling, ventilation. That's the separate. That's what most people are talking about when they talk about low carbon buildings or energy efficient buildings. But we're kind of basically talking about everything else, all the other carbon impacts of construction that are currently mostly overlooked and not regulated or managed very well. So when we look at global emissions, operation of buildings is the majority. You can see the red in this pie graph. It's about almost 30% of global emissions is the energy we use and the carbon we use to operate the buildings annually. But to construct the buildings in the first place, it's actually over 10% of global emissions. And we can see that that's broken down into cement and concrete is actually the single most carbon impactful material currently. It's about 8% of global emissions, so quite significant. And there are a lot of opportunities for us to reduce that. And the cement industry is making a lot of innovative strides. There's a lot of low carbon cement options available on the market, and this is one of the reasons that we really want to get this issue on people's agendas, because there are simple low-hanging fruit things that we can do to really drive down these emissions when we know the right questions to ask and we can get the right information to the right people in the design process at the right time. So as I said, these are a significant amount of emissions here we're talking about, and they are often overlooked and not well managed or understood. As Lisa said, we are starting to see regulation come in Canada and elsewhere, and I do have a slide on that later. But wanted to introduce the nomenclature that people use, or the different life cycle phases here. And you can see in this graphic, this graphic is from the World Green Building Council. They have a great report called Bringing Embodied Carbon Upfront. If anyone wants to dig into this a little bit further, I would suggest you to Google that and take a look. It's a really easy to digest report, but they pulled out this graphic, which is actually from one of the international standards that this is all based on. And they have these different phases, A1 through to C4 and even D. So each of these codes are basically a different life cycle stage where the emissions are being assessed and calculated within a study called a life cycle assessment. So you might hear the term LCA or life cycle assessment. That's basically the methodology, the approach that is being applied to a long-term project like the construction and operation and demolition of a building. We would apply this methodology called a life cycle assessment, and one of the outcomes, one of the metrics that we would get out of that would be the embodied emissions, which is often referred to as global warming potential, or GWP. So there's a lot of different terminologies, which unfortunately can be a little confusing sometimes. I think that's kind of standard when new approaches and new methods are being introduced to the industry. We haven't really all coalesced on a single set of vocabulary, so apologize on behalf of the industry about different terminologies, but the LCA is the methodology, the embodied carbon or GWP, global warming potential, is kind of the output of the LCA. And the one thing I really wanted to point out here is that we have different terminologies for the different parts of the assessment, but the thing I really wanted to point out is this section here called the upfront carbon analysis. And as Lisa said, low-rise construction in TGS V4 does have upfront carbon targets now specifically. So, and when we say upfront, we mean everything up until the building is occupied. So this is all about, pre-occupancy. It's all about where the materials are sourced from, the transportation, the manufacturing, and even the construction processes during construction. But that's where we kind of end. Once the building is complete and people are about to move in, that's the cutoff mark for upfront carbon analysis. And the other thing to say here is that this is the majority of the emissions, even though it might be smaller. It might be a smaller section than all the other phases in the future. Studies have shown that this is about 75 to 85 to even 90% of building emissions, depending on the project and the region. But it is the majority of the emissions. I would say 75 on the low end, 75% of the total life cycle emissions of the building is really from this upfront carbon. So this is all about where we're procuring our materials from, how they're being manufactured, how far they're being transported. Are we getting it from a local supplier or across the world? This graphic really shows that well. This is from the LETI, which is the London Energy Transition. So this is London, England. Again, they have a lot of really great resources on this topic. And this just shows that operational emissions, the annual use of the building, that varies from year to year with weather patterns or occupancy patterns. But the vast majority of the carbon impact from the embodied sources you can see is upfront. We have some other ones throughout the life cycle, maybe when we're replacing the roof, making some other big material changes to the building, but and then some at the end of life. But the vast majority of these emissions are in procurement. And this is another way to show the carbon footprint of these buildings. This is kind of a cumulative look at carbon that have been released. So I think of this graph as showing the carbon that's in the atmosphere due to a building in any given year. So, for example, in year one, at the end of substantial completion of construction, all the emissions in the atmosphere from that building are just embodied, right? It's all the stuff that has been emitted to get the building there in the first place. But then when we go to year 60, and we might have a much higher amount of carbon in the atmosphere due to the building running for the past 60 years than was emitted for the embodied section. But this split, this significantly higher operating than embodied at the end of the life cycle, this used to be true. I would say 10 years ago, 15 years ago, this was the common split of embodied versus operating for a 60-year lifespan of a building. But things have changed in the past 10 or 15 years, and there's two big changes. One is our buildings are much more energy efficient than they used to be because of things like the TGS, because of things like the Ontario Building Code that have more stringent requirements coming out all the time. A new building today uses much less energy than a building used to if it was constructed, say, 30 years ago. So that's item one. Item two is that our energy system is decarbonizing. So 1 unit of energy that a building uses today is much greener than it used to be. As I'm sure everyone on the call knows, the Ontario provincial government has phased out coal-fired electricity generation in Ontario. We're using more renewable natural gas in some of our natural gas systems. So when you combine the more efficient buildings and the greener energy, the carbon impact has greatly reduced for new constructions operating carbon. And now we're looking at something more like this, where the operating carbon can still be a significant amount of carbon. We still want to address it. We still want to find ways to reduce it. But the embodied carbon is now nearly as big of a piece of the pie when we're talking about new high efficient buildings. And it gets really interesting when we shift our time frame from 60 years to make our decisions to 10 years to make our decisions. So if anyone who's been following the IPCC, the International Panel on Climate Change, reports from the UN, they say, you know, we're in a code red climate emergency here. We have 10 years or less to make significant reductions to our carbon emissions, or else climate change is out of our hands. Positive feedback loops are kicked in and we won't be able to control it. So if we start to make decisions based on carbon in the next 10 years in a shorter time frame, you can see here that embodied carbon is actually the vast majority of emissions for high efficiency new construction. So this is really why this topic has exploded onto the policymakers' agendas across the world, because we've realized this is a blind spot in the building industry, and it's actually a very, very significant amount of carbon when we're talking about new high construction building. So those images were kind of, descriptive, but they weren't specific. This is specific numbers from a study that we did with the province of Ontario on new LEED Silver certified government institutional buildings. So this is actual values from a real project in Ontario of a LEED project that the government did, and we can see that those trends I showed on the previous slide they bear out in the data here, that we saw the embodied carbon of the structure was, a significant amount of the total carbon footprint in year 60, and it was the majority of the carbon footprint in year 12. For example, we used 12-year window here. And then the other thing to point out is that the red dotted line, that's the embodied carbon just of the concrete. So as I said, there's a ton of low-hanging fruit here, and we should really be focusing on the big hitters. Let's focus on concrete and cement. Let's focus on steel, insulation, glazing. Those are the top materials. We don't necessarily need to boil the ocean and get stringent requirements for every little material in a building, but let's start with the big hitters. And how we do that, the first thing we want to do is ask for something called an environmental product declaration, or an EPD. And I like to describe this as, it's basically a nutritional label, but for construction materials. So when we go into a store and buy food, we know when we look on those labels exactly what's in that material or what's in that food and what it would do to our body. But we don't have that kind of a label for the construction materials we're buying. We know what's in it and what does it put into the atmosphere when it's being produced. So that's basically what an EPD is. It's a report that will show you that. And EPDs can be quite long and maybe a little intimidating to interpret, but just like in a nutritional label, you're probably not looking at every little thing on the label. You're probably looking at one or two key things, like what's the serving size and maybe how much fat is in it, or carbs, or whatever you're trying to optimize for. Same thing on an EPD. You want to look at the functional unit of the EPD. How much of the material are we talking about here? So this is an example of 1 metric ton of rebar. And the one thing I would suggest optimizing for is global warming potential, or GWP, which is the carbon, the embodied carbon of the product. You can see, you might recognize these codes from the previous slide I showed, which was the different life cycle phases. So this is the total embodied carbon of this rebar from harvesting the materials, transportation, and fabrication. So this is a number that I would want to look at, compare against other products, and find the lowest value. That's basically how we would use an EPD. Just quickly to say that there are different types of EPDs, or different scopes of EPDs. So some of these are industry averages. For example, a North American wide average. The two EPDs at the top of the screen here are both Canada-wide industry averages for cement and for ready-mix concrete. So those are great documents that show you the general, across Canada, if you were to take an average, what the carbon footprint of a standard unit of cement or concrete would be. But there are other more specific versions, like a company or a product specific, or what we call a facility specific. So this is a specific product made at a specific manufacturing location, and there's an EPD associated with that. So this Permacon for a brick, for a CMU brick here, this is a specific product from a specific location. And you can see it says right on the title, Milton plant in Ontario. So the data in here is very specific to one product produced in one spot. So when we're trying to optimize this for our actual construction projects, it's best to have these facility specific EPDs that show you the actual carbon footprint of a one product from one location, as opposed to these industry average EPDs, which are still useful, but ideally we will move more to the specific ones over time. There's a lot of information on this slide. I'm not going to go through it all, but just to show you that there are a lot of policies being rolled out. These are all examples of different policies on embodied carbon. I will just mention that Toronto and Edmonton are now requiring embodied carbon for their city-owned construction. So this is the TGS version 4, which goes into effect on May 1st. There are other strategies at the federal level. The federal government has something called the Greening Government Strategy, which has requirements now for all new federal construction as of 2022, and they're aiming for a 30% reduction in embodied carbon by 2025. We're also seeing the city of Vancouver targeting a 40% reduction in embodied carbon. They're requiring all new rezoning applications to be reporting their embodied carbon, and limits will be coming on in place shortly. And also Waterfront Toronto requires reporting on their projects as well. There are many other policies around the world, lots in the US, lots globally. We don't have time to touch on those, but if anyone wants to dig into any of these more, I would recommend checking out the Carbon Leadership Forum website, CLF. If you type in CLF policy, they've got a great overview of different policies globally. And just to mention, there are some tools that can really help streamline these assessments. I know it's quite broad and it can be daunting, the scope of what we're talking about here, but with the use of some of these tools, many of them are free to use. Project teams can effectively manage the embodied carbon on their project. There are different, you can do LCAs or embodied carbon assessments at different phases of the design, and there's different strategies that you would get from doing it at each of those phases. So I won't go into detail here, but we'll share the slides after you so you can refer to this later. But we can do an LCA at schematic design. I like to call this a Class D LCA to align with people's thinking around cost estimates. This is where we would make high-level decisions like, what type of material are we using? Is this going to be a concrete building or a steel building, or maybe a mass timber or a wood building? What's the massing going to be like? If we can reduce our underground parking and have more active transportation, how much of a carbon benefit can those types of high-level decisions achieve? We can do a more advanced or a more refined model, what I would call a Class C, during the design development. And here we can get more into the specifics of optimizing the layout and the floor plans, and maybe a little bit more specific on the materials that we want to use. We can do a Class B or during the procurement or pre-tender phase, when we're just getting ready to issue those construction documents. And this is where we're really getting into the fine grain decisions about what's the recycled content in our steel, what's the amount of, what's the properties around the concrete in terms of the type of cement we're going to use. Is it going to be a lower carbon cement, which is available for a cost neutral and performance neutral, but we just need to ask our suppliers for that. Are we going to maximize SCMs? Can we change any of our mixes from standard 28-day curing to 56-day curing, which means we can use less cement and therefore less carbon? So there's a lot of, as I said, a lot of low-hanging fruit we can do that we can unlock with these types of analysis. And finally, we could do a Class A. These are terminologies that I'm applying, but they're not standard in the industry yet. But I like to think of a Class A LCA as a post-construction. This is a as-built model, and this is where we can really learn about what the final carbon footprint is, and maybe we would purchase carbon offsets to account for that carbon, so that we can claim the building to be carbon neutral. So I'm about to wrap up here, but some quick best practices to reduce embodied carbon. First thing is just to ask your suppliers. A lot of suppliers do have lower carbon options, but they're not being asked for them by the market. So ask what we can do to have a lower carbon product, and you'd be surprised what you might find. We found that super tall buildings, real big high rises, they actually have a higher carbon footprint because of the additional underground footing typically, and other material impacts, which Kelly will comment on in a little bit. For concrete, I mentioned some of these. Use Portland limestone cement. This is a 10% lower carbon impact. It's cost and performance neutral. It's readily available across Canada. Maximize our SCMs. Normally mixes are about 5 to 10%, but we can go significantly higher than that, and that can reduce our carbon quite substantially, and consider longer curing times, going from 28-day to 56-day for materials that don't require early strength, like slab on grade, footings, foundations, or shear walls. For steel, we want to use North American steel with high recycled content instead of shipping it from other parts of the world where they make their steel using blast furnaces and coal-fired blast furnaces. For wood, we want to ask for certified wood from sustainably managed forests. And there's things we can do about having a lower carbon construction site too. Let's try to use electric vehicles wherever possible. Let's try to use biofuels in our delivery. So there's a whole host of things we can do to really reduce the emissions. And then one thing quickly just to comment on is that LEED is one of the main drivers for this currently, and it only includes some parts of the project like footings, the structure, the envelope. There's a whole bunch of things that are excluded for a LEED compliant LCA, like mechanical, plumbing, excavation, and parking lots. So just to say, when we're looking at whole building LCA results, one of the first things you should ask is what's included in that, because it might not be everything. There might be significant amounts of materials that are being excluded from the model. So with that, I will hand it over to Kelly.
Right, thank you, Ryan. Going to move on to the next slide. So about 2 years ago, I approached the University of Toronto to lead a studio at the School of Architecture, looking at embodied carbon as a way to help catalyze this conversation, specifically in Toronto. And to do so, last year we looked at these 10 multi-unit residential buildings, and this year we looked at 10 mass timber buildings. And I think that what came out of this were some interesting findings that I then brought on to Lisa and have led to the study. So I'm going to show you some of the work from last year and also the work the study that we're doing right now, where that's at. Next slide, please. So the results from last year in a kind of just purely numerical format are here. So you can see of the 10 multi-unit residential projects, we had a mixture of a kind of lower rise to stick frame townhouses and a range of concrete mid-rise and high-rise projects, very typical of contemporary construction. What I look for is buildings that are either done in the last 5 years or currently in the ground. And the kind of first things just to look at is on a square meter basis is that the lower rise wood frame projects have roughly half the emissions of the mid-rise and high-rise. And of those mid and high-rise, they're about the same. It's kind of, you know, when you go from about 4 to 6 stories up to 30 stories, there's not a huge difference, I would say, on a square meter basis. But within the projects, there's actually quite a variation, and we wanted to understand why. Next slide, please. So the main key drivers of, say, embodied carbon right now in contemporary construction worldwide, but certainly specifically in Toronto, are the structural systems. We use a lot of cast in place reinforced concrete in Toronto. We are addicted to the stuff. It's cheap. We invented fly form, and it's the primary ingredient of our buildings, to use Ryan's analogy here. Low-rise projects that employ wood frame structures had roughly half the emissions of the high-rise, as I mentioned, and the lowest carbon mid-rise project actually employed a steel and hollow core slab system. So it did everything it could to reduce just the overall volume of cement and concrete in that project. Next slide, please. And here's a look at the 10 projects, the radius being indicative of total footprint, and then the colors indicative of the percentage associated with the material. So you can see concrete there, by and large, a big portion of all the projects. And then next is aluminum. Next slide, please. And that aluminum has to do with how we glaze and glaze our buildings, and also a lot of the envelopes so we wrap our buildings. And as an architect, it's completely the domain of architects and say building envelope specialists. And what we can see in contemporary construction is that we use a lot of foam, specifically XPS insulation historically, and a lot of aluminum-based extrusion systems or window wall systems, curtain wall systems, high glazing, high window wall ratios in Toronto. And as a result, our buildings have got very high embodied carbon, off the charts compared to some other parts of the world. Next slide, please. And here's a view of some of the envelopes. So on the left, some of the more lower rise townhouse envelopes here of wood or metal stud, kind of more typical rain screen veneer systems. What you can see, and on the right are kind of off the shelf window wall system here. So You see some key things. We wanted to know carbon intensity on a square meter. So the window wall is roughly twice that of, say, a wood stud wall or a metal stud wall with a brick veneer. And then from a R value perspective, it's not comparable here. So I think just beg the question, is this really a sustainable way to be designing and cladding our building? I would argue not in this specific lens. Next, please. The third, I think this is where things got really interesting for the conversations with the planning department, is the, say, unintended consequences of things like parking spaces or minimum parking requirements that pre-existed. And so, foundation works, parking structures, anything that we do below grade has a disproportionate impact on a building's footprint. So for the mid-rise and high-rise structures, up to 1/2 of a project's total emissions, we're not having anything to do with the provision of housing, but the provision of parking. Next slide. So here you can see the lower rise projects. Again, this is indicative, and you'll see Chris's presentation following mine. Our foundations, our concrete basements, our desire to go deep into the ground is really where so much of the emissions lie. And even with these projects here, you can see on the left just a kind of half basement, 2/3 of the project is in that condition. Next slide, please. And with the mid and high rises, a big variation here. River City 2, 22 Trolley Crescent, only 8% because of the floodplain there. That could not go down, which is a blessing. And then right beside it, a project in the Junction built on an underground river course, where they had to basically build a concrete basement to deal with the subsurface conditions. 50% of it of below grade. So I'd say, again, a kind of cynical way of looking at this is clearly this is not the behavior of a species looking to survive. We have to figure out how to get less of our buildings below the surface of the earth. Next, please. And the kicker on this parking is the dimensional impact in the structural grid. So if you've worked in this, you realize, the dimensions of a kitchen or a living room are not the same as a parking space. And so that to reconcile that geometry, structural engineers, as you know, we introduce a lot of structure to do that. And the next slide will show in one of the projects, this in Alex Park, where those two grids being off each other result in the entire ground floor of this project being a 1 meter deep concrete transfer beam to satisfy the parking requirements below grade. Again, when you look at this, I think once you see it through this lens, I think we have to think about how we move beyond this form of city making. Next, please. So, bringing this to I guess a broader audience here, an open letter I wrote to planners a year ago to think about how do we change the planning laws? What can we be doing at municipal levels to deal with this? Because so much like parking was unintended consequences of certain planning and zoning requirements. And that I think opened up a conversation with Lisa, and that led to the study. Next slides, please. That working with Ryan and Lisa and the team on for the last year or so through the funding from TAF. It's been the first initiative to collect and compare whole building life cycle assessments for Part 3 buildings in Ontario. It's obviously the clear connection with the Part 9 study you're about to see. The Part 3 buildings include commercial, industrial, institutional, and larger multi-unit housing. And as part of it, I think Lisa also had the foresight here to take 2 of the city's current projects that are in procurement and look at them through this lens to understand what would the implications be of a policy on projects, specifically city ones, but also what could we be doing in a design development phase of the project to be improving them. And we'll show you that as well. And the purpose of this is to feed into the future green standards. Next, please. So we got actually a pretty overwhelming amount of response. I think we had 51 responses. And here you can see a kind of plot of where all those responses are from. So we some of the data set came out of my own studio, and the others came from industry. So the kind of key things to take away from this is like, this is already happening in Toronto, which is fantastic. And of the data we had is actually pretty tight. These boxes, the 80th to 20th percentile, they're pretty tight. Certainly on that mixed use residential and the commercial office, you can see like the projects are all in around that same level. And I think through this, we're beginning to say this is the first benchmarking of its kind to then be pegging future policy against. Next, please. Here you can see where those upfront emissions live. It's by and large in that product stage that I won't go into that, as Ryan's just covered, but this is where we really need to be paying attention to, is like, what are we making our buildings out of and where is it coming from? Next, please. Where is it in a building? So I think, you know, per some of what I just showed, there's so much of it's in foundations and floors and beams and columns. Those three things are, you know, by and large, a lot of that's cast in place concrete and much of the building stock we're looking at. The walls are the envelope, and then roofs and extra materials. You know, those are kind of some of the interior finishes here. But if we really just think about, one thing to take away is like, how do we look at structure and design structure through this lens, and how do we look at envelope through this lens too, through a whole bodied carbon lens? You know, per the time scale that Ryan was looking at, you know, is a high performance envelope really the right thing to do if it comes with a big upfront footprint? Certainly in the context of a place like Toronto that's got a clean and green grid, I would argue probably not. Next, please. Here, one of the two city projects we got to look at, we looked at the emergency services building, the EMS building designed by Diamond Schmidt. We worked with the city's project manager and the architects to look at this. Another project we looked at with MGMA and GH3, some of whom I see on the call today. And the first thing we just like, okay, well, if we're going to go after some findings or some reductions, where are they? And so it's a good representation of, say, the scale of where the current emissions lived. And we said, okay, well, we could probably do something about that XPS and insulation. We could look at the steel. We could paintings and coatings stuck out as a little high too. Next, please. And so we came back to the project team through kind of doing a full study of it with some suggestions. And this was a project on a per square meter basis that was already very low. I think in those box plots earlier, it was on the low side. It employs CLT roof structure, has an incredibly efficient facade system. And even then with low, we kind of identified a 30% reduction in just cost negligible specification adjustments. So this was looking at the specific, to Ryan's point about concrete, the specific mix of concrete available, the specific insulation being used, and the sealant on the floor itself. And the design team went back, talked to their costing teams, design teams, easy changes to make in the design process. They came back and said, we're going to employ all of this. And it results in a 30% savings or 800 tons reductions over a 2-week study. And I think most encouraged, Diamond Schmidt came back and said that this report has gone viral in our office, and we want to take this approach to our project, all of our projects, which is exactly the kind of impact we were looking to have. Next, please. And so the next steps here, we're on the part 3 study. We're holding these workshops. The first is today with you all. We'll be doing one with manufacturers next week, with developers, building owners, and contractors in the middle of May, and with government officials, regulators come June. And then we'll be working together to put that together into a primer to be put forth to recommendations to the next version of the green standards. Thank you.
All right, thanks, Kelly, and thanks to everybody for tuning in today. My name's Chris Magwood. I'm with Builders for Climate Action and the Rocky Mountain Institute, and I was the lead researcher on the Part 9 study. We had a great team involved in this and a great partner in Passive Buildings Canada, and we were really excited to be able to undertake this study. Next slide, please, Ryan. So one of the things different between this Part 9 study and the Part 3 study is that we were provided with plan sets of homes in the GTHA from developers. So we were working from as-built homes, and so we were able to do the exact same analysis using the exact same tool on all of these plans. In total, we had 59 plan sets that represented, in the 2 years that the study was looking at, 503 as-built homes made to those plans. So it was a pretty, it was a good size of a sample. Gave us a really good sense that we were capturing lots from across the whole the GTHA, and that we would, the results would be very comparable within that data set. Okay, next. So just to, Brian talked about scope and so did Kelly, but For this study, we used a tool called BEAM, which we developed in-house at Builders for Climate Action. And it's just giving us results for the what we call the material carbon emissions, that upfront part that, that has to do with manufacturing the building materials. So we are not looking at transportation to site or installation. And again, we're sort of focused there because we know that that's where the big chunk of the emissions live. We're also looking at basically the structural enclosure and partition materials. So things that aren't included are things like site work, stairs, mechanical, electrical, and plumbing equipment, surface finishes, appliances, all of that kind of stuff is not included. So we figure, looking at some studies where all of those things are wrapped in, that we're kind of accounting for maybe 50 to 60% of all the embodied carbon in the houses we're looking at. But we focused on this range of materials for a couple reasons. One is it's the set of materials where we have the best data set. We can represent all of the materials in a really good way, whereas lots of the ones we left out, there just isn't very good data for them. And we also feel that these are the materials where a lot of action can be taken by somebody to reduce those emissions. You know, the only way you're going to reduce your mechanical and electrical and plumbing emissions is to plumb less or wire less, and that doesn't seem like a change that we would be driving with this study. But you can, you know, think about your structural materials, your insulation, your windows, you know, all of those things. Really big reductions can be achieved in those material sets. So we'll go to the next one. So this is kind of the plot for what the emissions across this whole study looked like. We looked at 3 different typologies: semi-detached, single-detached, and townhouses. And you can sort of see those first 3 boxes on the left. The single-detached houses in general had a higher carbon footprint because they're bigger and because the entire enclosure of the building is being attributed to that one residence. And you can see that semi-detached on the left is a little bit less overall, and the townhouse is less again. And so, you know, that's interesting from a planning perspective, that, you know, if we want to drive overall emissions down, thinking about grouping houses, that, you know, townhouses are a good way to go. But essentially, we're looking at just under 43 tons of emissions per house for the structural enclosure and partition materials. Okay. However, we didn't want to just use the lens of overall emissions because the size of the units matters. And so if we look at emissions per floor area, you can see that the results really tighten up on the left. That's the total floor area. So that would be taking in garages and any unheated space in the house, so unfinished basement areas and things like that. And you can see that you know, suddenly the results really tighten up because we're attributing emissions to the size of the building. So obviously, if you make a tiny house, it can have a lot less emissions than a really big house just by the volume of materials. So by looking at it by floor area, you can see that actually these Part 9 buildings fall within a pretty tight range. We also looked at it by heated area. So this would be sort of wrapping the garage and any unheated basement space in, so that you're actually sort of paying a bit of an embodied carbon penalty for that. And then even further to the right is habitable area. So making sure that we're really only attributing emissions to the places where people live. And you can see at each of those phases, it goes up a little bit. But the interesting thing here is that, you know, we did find over such a large group of homes, a fairly tight range in which all of these landed, especially when we look at it per meter squared. Okay, next. So this just kind of sums that up for the heated floor area. So the carbon intensity ranged from a best case of 116 kilograms per square meter of heated floor area. The highest example in the study was 561 kilograms per square meter, and the average landed at just over 191 per square meter. So, you know, you can see that there's a pretty wide range there. but a lot of the buildings were clustered really closely around that average result. We were also able to look at the impact of different material categories, and very similar to what the Part 3 study found, we found that just 3 material categories, concrete, insulation, and cladding, accounted for 72% of the total material emissions. So, you know, if we're going to really try to make a difference here, these are the areas where we want to concentrate. You know, things like roofing, framing, post and beams, windows, all of that stuff. You know, there are certainly savings to be made there, but the lion's share belongs in just those 3 categories. And so that's where we would recommend that we kind of pay attention in the low-rise market, is to making reductions there. Okay, next. So also along the lines of the Part 3 study, we took a couple of the buildings from the study and looked at making some material changes. Same kind of parameters as with the other study. We wanted to look at you know, achievable, affordable, code compliant type substitutions that could be made. So we started with a building that had 81 tons of emissions, or 262 kilograms per square meter. And we did things like use a lower carbon concrete mix, then substituted cellulose insulation in place of the other insulations that had been used in that building. Took the XPS foam wrap around the building and substituted wood fiberboard, changed the brick cladding for engineered wood cladding, and took a bunch of the other categories like flooring and drywall and didn't change the material, but just changed to the best available product, the product with the lowest emissions in those categories. And you can see it's pretty remarkable that that brought about a 75% reduction in those emissions. So we went from 262 kilograms per square meter down to 66 with just a small handful of substitutions, all of which are doable and achievable today. And then if we go to the next one, this stood out to me as being really interesting. So this is an overlay on the graph you just saw. So you can see now we're looking at one of the houses that had the lowest carbon footprint to begin with. So that little orange box on the left, it started with only 33 tons of emissions associated with it. We applied all the same substitutions, and we ended up at 56.5 kilograms per square meter. And the previous house landed at 66 kilograms per square meter. And we saw this over and over when we made substitutions that in effect, it didn't have to do with the design of the home or the location of the home or the typology. If you sort of chose the best available materials, they all kind of, you could get all the houses into that sort of like 50 to 75 kilograms per square meter range. So really interesting to see just how much savings there is available to us in emissions in this low-rise sector.
Chris, sorry to interrupt, but one really important question came up in the chat that I think you'd want to address. They said a 75% reduction in carbon at what cost?
Yeah, that at no cost or very negligible cost. There in some cases the material we're substituting is actually cheaper than the one it was replacing. In fact, in a couple of the main categories, that's true. In this case, the lower carbon concrete doesn't have a cost penalty. Moving to cellulose insulation looked cheaper. The wood fiberboard is more expensive than the XPS. The engineered wood cladding was cheaper than the brick. And in the flooring and drywall categories, it was just a brand choice. So, negligible cost there. So I think we see that in general, you could achieve that suite of changes at or about the same cost. It might be a little more, it might be a little less, it might be on par, but there's really not a heavy price penalty to be paid here. And I think if you do this smartly, there could be no price penalty. And in fact, the house could be cheaper. Thanks for directing that one, Kelly. So I just wanted to show you, we have done some other studies for other regions. We did a study for Enercan, looking at model homes across the country. And we also did a study for the cities of Nelson and Castlegar in BC. And what's interesting is, we found that the ranges, especially in the sort of worst results and the average results, are pretty close across the country, which gives us a sense that, you know, the results we're seeing in Toronto aren't necessarily unique, but that, you know, kind of everything in average landed between sort of 150 to 190 kilograms per square meter. Okay, next. And this is where I was going to sort of bring up the cost issue, because one of the things that really stands out from both the Nelson study and this GTHA study is that, you know, none of the builders who submitted plans for these studies are building buildings to intentionally have a lower carbon footprint, right? They're just sending us the plans that they're currently building now. This fits their business model. It's what they build, it's what they sell, it's how they make their living. And it's interesting to see that, you know, there was a whole cluster of homes in the GTHA study that came in around that 116 to 120 kilograms per square meter. That builder was not intending to make a low carbon home, but they're beating the average by 40%, which means, you know, somebody's business as usual is already 40% less than the average. And, you know, when you compare that to some of the higher results, it's a huge achievement. So even if we can just get everybody to be doing the thing that this builder is already doing, that's a 40% reduction. We don't get easy 40% reductions in the climate change space very often, but this really points to that being possible. And the same thing happened in Nelson. You know, there's again, a builder just building the house that they always build, and beating the average by 50%. So, you know, it tells us that there's a lot of room, and that we don't have to sort of, initially anyway, go very far out of anybody's comfort zone to see, you know, 40 to 50% reductions in this building space. Okay, next one. And so this was, you know, I definitely invite you to go download both of these reports. There's a lot more in them than we're able to cover in these 10-minute sessions, but the final recommendations for the Part 9 study, we recommended that all new home designs do this kind of calculation at an early design phase, and that we sort of recommend that municipalities ask for that report in the permit phase. That everybody, you know, in this call, designers and builders, request EPDs from all the manufacturers. I noticed there was some notes in the chat saying, you know, are there enough EPDs, or I couldn't find product-specific EPDs. And I think, you know, I've seen the number of EPDs really explode in the last couple of years. And that's because, you know, people are demanding them. And I think the more we demand them, the more complete data set we'll get, the better, you know, we'll be able to specify the products that meet our
one omelet, please.
Yep. Yep. Should I warm up for you?
Somebody is ordering lunch, not on mute. So if you could mute, that would be great. Thanks. To explore these immediate potentials for material substitutions that I mentioned. And again, the report goes into a lot more depth than that, where we can easily see sort of a 20 to 50% reduction from business as usual in a really sort of simple and cost-effective way. The report also goes into looking at what materials could move us even further along that path. Some things that, you know, are kind of coming or not as common in this market, but are being used elsewhere, that can actually get us between 50 and 100% reductions. So, you know, start looking at that now, start thinking about that, start planning for that now. Our study didn't look at design options for achieving reductions, but as Kelly mentioned with the large building study, you know, if 35-ish% of the carbon footprint of all of these homes was in their basement, was in the concrete in the basement, you know, one simple strategy that we didn't explore here because we were using as-built plans, but, you know, thinking about the actual design of the building as a way to reduce the carbon footprint further. And then finally, you know, we would encourage residential builders to, you know, start declaring the carbon footprint of their homes and, you know, pushing to get really great results, and then using that. You know, surveys show again and again that, you know, 60 to 80% of Canadians are very concerned about the climate and want to make choices that are sort of climate smart and climate friendly. And I think offering homes that can show that they're, you know, 40, 50, 60% less carbon footprint than a competitor's is going to be a real advantage. So, sort of making these results part of the discussion around building and buying homes. So that's the Part 9 report in a nutshell. And I look forward to speaking with people interested in the Part 9 study in the breakout that'll come after this break.
Here, we had a really great discussion in the Part 9, the Part 3. Some of the main things we heard was we need for more education and sharing and dissemination. So we're going to be sharing our policy primer with all the municipal governments in Ontario. So wherever you're located, when that goes live in, I think it's June, July, please, become an advocate for this. Bring it to your elected officials. Say, we need to work on this. We need to have training sessions. We need to have public engagement. So really, we all need to be working on this in our own networks to really get this moving at the speed it needs to be. And then we heard some notes about prioritizing reuse of buildings, reusing existing construction, and decentivizing demolition. So that's taken into account, and we're looking for strategies to do that, because we realize the lowest carbon building is the one that's already been built, right? So that's very much on the agenda on ways that we can optimize reuse and make that part of whatever policy comes out of these discussions. And then finally, and then I'll turn it over to Chris for a couple words, but one of the last things we heard was, the first bullet was, what are your thoughts on a reasonably easy to achieve target that goes down over time? And we actually heard some folks say it should be a little bit more difficult. People should have to work to try to get to the target, because we don't have time for 2 or 3 revisions of the TGS and having multiple years before we start ratcheting things down. We need to be moving faster than that. So some really good discussion around those points. Chris, do you have any updates from your call?
Yeah, I think in the Part 9 room, we talked a lot of the same things, the need for education broadly, including, students who are in school now, across the trades, within municipalities, everywhere. A lot of discussion about, EPDs, where are they? Where do you find them? How do we get more manufacturers to make them? We did have some good discussions on some actual materials and strategies in there. So yeah, it was really good. I think in general, the group that was in that room seemed really engaged and motivated, and I think exciting to see how quickly the interest and the momentum in this has built over a fairly short time.
That's great. I'll turn it over to Lisa for a couple final words, but I just wanted to remind everyone that this is the first of 4 interactive workshops we're holding. Each has a different audience. So the next one is for manufacturers next Friday. So if anyone can share this with your networks, if you found this valuable, and I mean, we're not going to kick people out if they're not a manufacturer next week, so other people can still join, but the discussion, we're going to try to focus a little bit more around manufacturing. And then there's another one a few weeks down the road for constructors or building owners, and then there's a final one for government officials. So just please share links to these with your networks, and we will make sure that we send around slides and recordings to everyone that attended. So I'll just hand it over to Lisa.
Yeah, thank you, Ryan. I wondered, do you think Ryan and Kelly and Chris, would it make sense to invite anybody who wasn't able to offer their comments or suggestions? Could they maybe write those in to us in response to the questions that we had? Because we are really interested, in your feedback and your suggestions on what we do next, and also your questions, because we'll make sure we answer those in the primer as best we can. So if that might be possible, maybe Ryan, there's a way to facilitate that. I don't know if you want to just use your email.
We did actually create an email address for the study. It's just zerocarbon@mantledev.com. So we'll welcome any comments there, and we can reply to them.
Yeah, excellent. And so basically, I just want to thank all the presenters. And, I really enjoyed, too, the kind of pop-up presenters we had in our session. I thought that was really interesting to hear about how, in certain firms, you're really modeling leadership there and showing how you can learn within your companies from the studies that you do, and then integrate those best practices into your projects. I mean, that's really how it has to work in terms of moving this forward quickly. And all the comments I heard were very relevant to helping us finalize this study for sure. So thank you all so much for taking the time today and staying a little bit longer. We really appreciate your input.